Write the expression as a single logarithm. Here are a couple of examples, A and B. First thing you want to do is have all the log properties memorized. And what I mean by memorize is you should be able to cite them from memory. So obviously there's going to be a few log properties that we're going to use. If we're writing this as a single logarithm, we actually want to condense this. Okay, we want to be able to write this where we are actually making the expression more compact. So let's recite some of those log properties from memory. For instance, what if you have a logarithm with a constant in front? So here's a logarithm, and with a constant in front, the constant is called p. Then what we could write is log base b n to the p power. Another good one to cite is, what if you have log base b of capital A plus log base b of capital B. We could write that as log base b of capital A times capital B. Another good one to know is, let's say you have log base, let's say R, capital R, minus log base b of capital S. Well, that's simply going to be log base b of R over S. Like that. So using at least these three log properties, let's see if we could write the following expressions in a more compact way. From left to right, we can see that this is and there you go. You've written the first expression as a single logarithm. In a similar fashion, you could do example B. The key, though, is once again, you're probably going to read this from left to right, and once you do that, you realize certain things can be easily or more easily simplified. This time we have the fifth root of z times what? Times y cubed. Finally, we're going to write this as a single logarithm. With the y cubed here. Fifth root of z all over x. And we can circle that. Let's just recap what took place. So right here, there's a coefficient of 6 in front of this logarithm. So we went ahead and used this property, the coefficient of p in front of this logarithm. Then we write log base b n to the p. And that's what happened here, and here, and here. Then reading this from left to right, we perform the order of operations, right? I mean, it is just order of operation in our case is P, E, M, D, and then we have what? S and A. Over here, the order of operation, of course, is P, E, M, D. This time it's A and S. Remember that these are ties, and this is a tie. And we break these ties working from left to right. So that was my emphasis about reading some of these expressions from left to right. So remember, these are a tie, and this is a tie, and we could break those ties by working left to right. Going back to what we did, from this step, there's a subtraction first, and so subtraction here is actually going to be first because we read this from left to right, and the subtraction is going to break the tie between a subtraction and addition. So we do the subtraction property first, and that's this one right here. Then we simply write the plus, the additional logarithm, and now we are on this property. And we could actually write the log base b of now a product. For example B, very similar. The coefficients go up. They go up to the base, that's right here. This time, from left to right, it's actually addition first. So that's going to break the tie. We're going to do the addition property first, then the subtraction property. And now apply the subtraction property, and we get this. And that's it.